We continue neetcode for 60 days. Today is day 20, and let's continue. Actually, I implemented this, and it looks like the following. So we have our asteroids, right, that should collide, and in case stack is not empty, and we have a positive value on the top of stack, and the next one is negative, right, and and the top of the stack is less than this value, so we just pop in all values, because like negative is greater, so it's like collide all these values. If we actually cannot collide, so if this value becomes less, then we check here, and we check, so if peak is greater than 0 and is less, but they can so they becomes equal, for example, so then we like collide once again, right, and we continue. If they're not equal, we so we just continue, and we just continue if this is less. In all other cases, we actually push it our stack values. So yeah, quite simple, but during the interview it's something that it's hard to maintain. So let's mark it as done. So let's go to the next one. So it's daily temperature. So this one is quite famous algorithm. So I just know it without even reading the description. So we have an array of temperatures. So let's say like 1, 3, 4, 2, and 0. And our task is to return the array of days of how much we should wait to get a warmer temperature, right? So what we can do, we can put onto the stack, and while this days is less, we just update our value. So first we just put into stack, and here we should like wait 1 day, here 1 day, and here 0, because all these days it's not less. And here, for example, we have another array. So here we wait 1 day, 1 day, 1 day. So we put 73, then we put 74. When we put 74, we check that 73 is less, so we can actually calculate for 73, and and then we have 74, right? Then we have 75. So for 75 we also can for 74 we also can calculate and push 75. So if value is less, we just push into our stack. And for example, when we reach 72, so we can actually collide all these two values from the top of our stack. So we know the current value, right? And we can just decrease and calculate the indexes. So let's create our result. It would be temperatures length. Then what we do, we have our stack. Then we iterate over our temperatures. We iterate with index. And here what we can do is we can check while stack size is greater than 0 and stack peak is less than temperatures I, we should start taking out from array. So we have in J that it will be equal to I, and here we should put into our result array J minus minus, even like this, stack pop, and then we just stack push our value with temperatures I, and we return results. So let's debug this this example. So we have our result array that actually is 0, like all these values are 0. So here we have like 6, 7, 8, 4, 5, 6, 7, 8, yeah. And then we just iterate over each of this value. And we have also our stack that is empty. So we iterate, so we have 73. So stack is not greater than 0. We can just have like is empty false. So stack is empty. So we just put 73 here. And we iterate for the further. So we have 74. And 74 is so temperature is greater than 73. So we can put into 0 position 73. So we pop from our stack, and stack becomes empty, and we pop 74. Then we go here, we pop 74, we put here, we put 75, then we have 71. So stack in this case is not empty, but 71 is not greater than peak, right? So we just push 71 here, and then we go 61, it's again less, and then we have 72. So 72 is greater, and 72 is currently on which 0, 1, 2, 3, 4, 5. So on position 4, 0, 1, 2, 3, 4. So on position 4, what we can do? We should calculate how many days. Okay. So we should not pop, but we should calculate how many days. So it should be I. Yes. How many days? Yeah, we go 1 back. So it should be like I. So here we don't need this one. No, actually we need this one. So we need J and J minus I, maybe. J minus I plus 1, and then minus J. So let's calculate once again, because yeah, I see the problem here. So here we just put 73, then we have 74. Let's have here on index 1. So we have 1. So we put on 0, 1 minus 1 is 0 plus 1. So it should be I minus j. Yes. So we put 1, then we put 74, then we have 75, and here on 75 it's like 2. So, but on position 1, we should put we should put the difference between them. So 75 minus 74, and we should put difference, and difference would be 2 minus 2 plus 1. 2 minus 2 plus 1 is become 1. So we put here 1. But wait, when we here, it would be 1 minus 1 plus 1. It will be again 1. Yeah, so it's not correct. This should be something like this. Yeah, it should be something like this. Oh, okay. Temperatures stack. And we need actually also to pop from our stack value. So let's do once again. So we iterate, we take here, it would be 0. Stack is empty, we just put 73 on the stack. Then we go here, it's 1. Stack is not empty. Stack peak is 73. 74 is greater. So we pop 73 from the stack and decrement j by 1 would be 0. And we put, so here we should put like this, but here it should be 1. So this one is incorrect. So it should be 1. Here it should be days 1. So let's put it days. And also we should increment days. and decrement j. Yeah, so it's not correct. Right. All right, so let's put, just do simpler. So we just put here index and, we can just put indexes actually. Right, so we can put index. Yeah, I think it's much more simpler. So I don't need this one. So I just put index and here I take temperature stack peak, right? And then here it would be result and index. Okay, so let's think what index it should be. Result. So stack pop. It would be, let's say, j. And I is where we're standing. And then we put result on index j. We should put I minus j. Let's run. Yeah. Submit. Yeah, and we are done. So let's compare to our previous submission. Yeah, so we see that it's actually the same. It's actually the same. And yeah, so we're done with this task. Pretty interesting one. Here we also have I indexes. Here also indexes. Yeah, so here we have this pairs and also pairs. Here, yeah, something different. All right, so we're done. I'm like, why it's so slow? We can also have DAC. Yeah, I think this DAC may be faster. Okay, and even like this, something very fast. Okay, but yeah, I think it's much more complicated. All right, so yeah, I think that's all for today. So we actually solved one task, and I think that's good. So see you tomorrow.